Hello, hello, welcome. Welcome everyone to our free Gmat prep hour. Hello, hello. Let me know that you're here by jumping in the chat window and saying hello. Let's make sure you can hear me. You can send the message to all panelists. You can send it to panelists and attendees. Either one of those is fine. It is a pleasure to see all of you guys tonight. Hello, hello. Do me a favor, type in the chat window for me. How long have you been studying for the Gmat? I want to get a sense of how long you've been studying. Okay, a few weeks, a couple months, a few weeks. Very cool. On and off. Okay. I love the 1 month, 11 days. 3 whole days. 9 months on and off. I really like the specificity though. I have been studying for 2 weeks, 4 days, 6 hours, and I hate it. No, I'm kidding. Well, welcome you guys. Welcome, welcome. My name is Whitney. I am in Durham, North Carolina. I have been a Gmat instructor for Manhattan Prep for just over a decade now. I just had my anniversary. Yes. I am super excited to talk about tonight's free Gmat prep hour because we're going to cover one of my favorite topics. It is the topic of picking numbers and plugging stuff in. So here's the thing. When you go to take the Gmat, you're going to think it's a math test. And because of that, you are going to try and pretend that you are in 7th grade again or 8th grade again, and you're going to try and do all of the formal algebra that your middle school teacher would have been so proud of. And the reason for that is that the last time many of you did this level of like formal-ish algebraic level math, you were actually in middle school. You were probably 12 years old to 14 years old, somewhere in there. And so you're going to try and put yourself back, right, in that headspace. How many of you guys constantly say to yourself, I haven't done this stuff in forever. It's been years since I've seen this stuff. How many of you guys? Yeah, right? Like that's like the first thing. Oh my gosh, I haven't seen this in forever. I don't remember exponents. I don't remember these rules. Yeah. Here's the thing. Is 7th grade you know, like 12-year-old you, 14-year-old you did not have a lot of intuition about like the world and how it worked. And so you really only had algebra rules to follow. And they're very lockstep, very like, write these variables, write these equations, solve it this way. The fact is that adult you has a ton of good intuition. And it's actually far smarter than middle school you. You just might not remember all the rules. The thing is that the Gmat is not a math test as much as I want you to think it is. It is a test of quantitative reasoning. So can you logic with numbers? And the fact is that adult you absolutely can logic with numbers, or else you don't shop at the grocery store, you don't tip someone who's, you know, waited tables for you, you don't figure out how much something is on sale, you don't split bills with friends, right? All of these things that you do on the day-to-day, right? Come up with recipes. All of these things are you doing math. You're just not doing them in the way that, again, your 14-year-old, his or her teacher would have necessarily forced you to do it. So what we're going to do tonight is we are going to talk about how you can turn this like 7th grade, 8th grade misery algebra into the sort of number crunching that you are quite good at. And by making things real, by having real concrete numbers in place, our adult intuition can jump in. And now we actually get to be our smart selves on test day. Because the thing is, you guys are already smart. You're very, very smart. What happens when you try to make yourself the 7th grade version of yourself is you strip away all of the most intelligent pieces of you, right? The part of you that has adult intuition. Yeah. So we are going to work on that tonight. Just so you know, if you ever need more free options from us, we've got plenty. You can always try a live class, right? So any session 1 of any of our classes are always available. So you can always jump in on any one of our complete courses. And then we also have our interactive product, the on-demand, that you can try for free as well. So by all means, right? Don't stop at just the free prep hours, although keep coming. We cover something different every time. But if you'd like some other free options, we've got plenty. So tonight, the plan is to talk about picking numbers. We're going to specifically cover problem solving. So this is a quantitative lesson, and we are focusing in on just problem solving problems. So we are not looking at data sufficiency. For those of you still very new, the 2 days in, 3 days in, problem solving is Gmat's version of multiple choice, right? It's just got 5 answer choices. You pick one of them, right? So the GMAC just calls these problem solving. So if you were to go look it up on their website, this would be what they would call them. Our job is to figure out, well, how are we going to do that? How do we pick numbers, right? When do we pick numbers? But the more important piece is, how do I recognize that this is a viable strategy? Because that for me is the important part, right? If you were sitting down doing a problem and I said, oh, this is a great one to plug numbers in, that'd be fine. But on test day, you have to figure out, is this a good number to plug in? Or is this a good problem to plug numbers into? And I need you to be able to do that on your own, right? Because I'm not going to be sitting over your shoulder. They won't let me. Yep. So your job is going to be to figure out how to recognize these problems. So we're going to start with a problem. So we're going to work on quite a few problems this evening. Yeah, we can use like picking numbers for word problems. There was a great question in the window, right? We can use them for word problems. We can use them for what would feel more like number properties problems. We can use them for algebra problems, for fractions, decimals, and percents problems. We can use them for everything. Right? So plugging in numbers, we've got some fancy names for them, things like smart numbers, testing cases, right? Like that sort of thing. But really at the heart of it, it's like pick your own numbers and plug them in. We are trying to move from theory, which would include algebra, into the concrete, which would be arithmetic. Right? So theory to concrete. All right, let's try one. I'm going to put, this one should move a little quickly, but I'll put 1:45. So normally for problem solving, you get 2 minutes, but just in terms of having time to work, I'll give you guys about 1:45. Do me a favor, change your send for the chat. So one little drop down, change it to just all panelists. Right? So we're not going to send it out to the public. As soon as you've got an answer, plug it in. Here you are. Good luck. All right, I got a bunch of answers in. And in fact, I got a couple of answers from people who said, well, I didn't really plug in. I used theory for this question, which is technically fine, right? You could use theory for this question. But what I like to practice, so even when problems are on the easier side, what we want to do is practice utilizing techniques or strategies that maybe the question's too easy for, but we want to practice the strategy so that as the question gets harder, we have that strategy available. So for sure, you might be able to look at this problem, and as a couple of folks mentioned, the fact that answer choice C is 4, an even number times P, then it doesn't actually matter what P is, 1, 2, 3, 4, 5, 6, whatever. 4 times that number is going to be an even number. So 4 times anything will be even. And then if I subtract one even number from another, I'll still get an even number. So that might be enough, right? You might be able to do the theory, but let's say it wasn't so obvious. I'd want to be able to plug in. And so all they tell me is that P is an integer. That means any integer, positive, negative, or otherwise, 0 included. So which of the following must be even? We want to test out some cases. So let's start with a nice easy one. P is 1. So this one would give me a 2. So that one works. 1 minus 4 would be a negative 3. That's an odd, so we would eliminate it. The key here is which of the following must be even. And since this one is not even in this case, we can kill it. And so we'll do that with all of the remaining, and we end up being able to kill off 3 of our answer choices. From here, we pick another number. Since we picked an odd, P is 1, let's pick an even, since we're in this universe of even versus odd. Here we have 2 plus 1 is 3. That would kill off that one. Here we've got 8 minus 2 is 6. There's only the one answer choice left. I don't need to test any others. So in some ways, this is going to be one of the easiest tells, so to speak, of when can we pick numbers. Right? And when can we pick numbers is often going to be this like must be theory, must be true, must be even, must be negative, must be greater than 1, must be divisible by 4. Right? So this must be language. And in fact, the could be language is often going to say plug in some numbers. And you're going to pick something small and easy enough to plug in. So since that last one maybe was a little easier to do with theory, let's see, right, if they're also easy to do with theory. So give this one a go. Okay, so this one not getting as many answers as quickly. Not getting as many answers as quickly. All right, so let's take a look then. Right, we've got integers greater than 4, and so we'll plug them in. And so we can look and just start, and we'll just run through one, and then we can test them out. But let's let P be 5, for example. right? So if P is 5, then our first one would be 5 times 4 times 7. Is that going to be divisible by 3? 5 times 4 times 7. What do you guys think? No, and here's where the shortcut. None of these 3 pieces are going to be divisible by 3, so the whole thing will not be divisible by 3. So we're going to try this again. We've got 5, 3, and 9. This one will definitely be divisible by 3, so we keep it. 5, 1, and 6, also divisible by 3, so we'll keep it. And then 5, 0, and 8, divisible by 3. And 5, -1, and 10, not divisible by 3. What happens if we plug in P is 6? And just went to the next one. Well, they're all going to be divisible by 3, right? Because this will be 6 in each one of those. So let's try the next one. If P was 7, then I've got 7 times 5 times 11. That one's not divisible by 3. 7 times 3 times, well, that one's going to be divisible by 3. And then 7 times 2 times 10, which is also not going to be divisible by 3. We're not going to do this problem with theory. It's just not going to happen. Right? We're not doing this problem with theory because it'll take us forever. This is a perfect example of must be, where we can plug in our own numbers. Okay, so let's start our list, right? So we've got our list. We want to think about must be true questions, particularly those that deal with theory. And we want to be ready to try 2 cases. Let's try a different type of problem and see if this is something that we can use to plug in our numbers. And again, I'm going to give you just under 2 minutes. More than anything, I just want you to try and get started. I don't need you to have an answer. So there's all the I just keep going back to theory. I keep going. Here's what you've got to do. It is a choice, right? You're going to want to do algebra. The fact is that's fine when the problem is on the easier side. But there will come a point for all of us when the algebra becomes too messy or too time consuming, and we have to trust our ability to plug in. And we can only trust that if we've practiced it. So if you did plug in, I want you to raise your hand if you tried to plug in some numbers for this. Nice. So what do I want to do? I want to pick a number, right, with Y dollars. 5 oranges can be bought. Now here's the trick though. I don't want to pick 5. I don't want to just repeat a number from the problem. I want to be a little bit creative. So let's imagine that we have 15, right? So let's say Y is $15. We'll pick something a little weird. And that means that per orange, because I can buy 5 of them, per orange, we're spending $3 an orange. And so I want to know, how many dollars do 25 oranges cost? Well, 25 of them is going to be $75 at $3 a piece. Now all I'll do is I'll take my Y, I plug it into my answer choice, and I look for the answer choice that gives me 75. So 15, and we don't have to spend forever, right? I don't have to run through it. 15 over 5 is too small. 15 is too small. 15 plus 5 is 20. That's too small. And then I'd want to find, what is 15 times 5? So 5 times, well, 15 can be written as 10 plus 5. Since we have to do math without a calculator, this becomes 50 plus 25. There it is. There's my 75. Right, 25 is going to be way too big. So we can plug in our own numbers. This is the second most obvious. Right, for you poker players out there, this is the second type of problem that has like a really good tell. And that tell, that giveaway, is variables in your answer choices. So anytime you have variables in your answer choices, it can be really nice to pick your own number. Really nice. So let's try another and see how it goes. I'll give you 2 minutes. And I'm gonna bet that some of you guys are still working. This was not an easy problem at all. But I had this wonderful conversation in the background that was like, all right, Whitney, let's be real though. Are you actually plugging in your own numbers when they're easy? And my answer to that is that they're only really gonna feel super easy when you're practicing. Because when you're taking the real exam, don't forget it's adaptive. And so it's not gonna necessarily feel super easy in the middle of the test. So what you want to be able to do is recognize quickly, is this a problem where I could plug in my own numbers somehow, right? I'm gonna pick some numbers for myself. If it is, then I get to ask, is that how I want to proceed? And on test day, you might say, oh, look, variables and answer choices. I could probably plug in if I want to. And then as you read it, you go, oh, but the algebra feels pretty good for this one. So I'm going to use the algebra for this. But then 3 questions later, you might go, oh, this is another one where I could plug in. And you know what? This algebra seems tedious. So I'm going to plug in for this one. Right? So what we want to do is think about, how do I recognize them? Because guys, algebra is always going to come to mind. right? No matter what problem hits the screen, you're already going to think, let me do some algebra. I want you to think of the alternative beforehand, because if you don't first think, oh, maybe I could plug in if I wanted to, then you're only going to consider that method after you've gone way down some algebraic pathway that has left you with nothing, right? I don't want to think of the escape route after the accident has happened. Why do you think that on airplanes, they tell you where the escape is before you even take off, right? They don't want to wait until something happens for them to then point out where the emergency exits are. So same idea here. I don't want to like save my emergency exit methods for only the moments where I desperately need them. I want to know where they are all the time so that I can quickly move to them as soon as I want, right? So for something like this, Seamus has 3 times as many marbles. So we've got Seamus compared to Ronit, and then Taj is compared to Ronit. So if I knew how many marbles Ronit had, so I'm not going to pick something like 1, but I will pick something smallish. So let's pretend that Ronit has 2 marbles. So Seamus has 3 times as many, so it'd be 6. Taj has 7 times as many, so that would be 14. Seamus is S. Oh, okay, cool. I already set that. Then in terms of S, how many marbles do they have all added together? Together they have 22. 22. And so I want to plug in 6 into my answer choices and see which one gives me 22. Well, 6 times 3 over 7 isn't even going to be a whole number. Multiply this by 6, the 3 would cancel, this becomes 14. Multiply this one by 6, the 3 would cancel with the 6, and that would give me 22. This would be 7 times 6, that's way too big, and 11 times 6, which is also way too big. And so the only possible answer is C. So definitely harder. And a person like sort of pointed out in the background that the first 5 questions they saw on a practice exam were super duper hard, like all crazy hard problems. And that's possible. It can sometimes shake out that way. But do know that even in some of those types of problems, you can still use alternatives like plugging in, right? Weighted averages for sure, work problems for sure, probability, statistics, like these are all problems where these methods work. So when I talk about alternatives, right? When I talk about alternatives, and let's check that, I got a message in the back. When I start to think about these, what I want to think about is that these aren't content specific, right? These are strategies that can be used across all content areas. They are broadly applicable. The quick check though is 21 for what? So someone said they used 21, but 21 for who? Yeah, that'll usually do it. All right. So we can start to plug in, right? If I know there are variables floating around in my answer choices, that is yet another way that I can plug in numbers, right? What we want to do when there are variables in our answer choices is choose simple values, right? And then we'll plug them into every choice. So we'll look for things like, you can pick values like 100 or common denominators, but you want to choose simple values, just maybe not the most overly obvious values. Okay, now let's try another. I'll give you again about 2 minutes. Oh, and a great question, Luna, is picking one a good idea? No. I almost never choose one when I've got variables in my answer choices. I don't choose 1s or 0s because it makes funky stuff happen. So I just try to get a little bit creative. Not crazy, just a little bit. All right, so we could start to think about this again using algebra. Like, all right, let's call the computer is X. So then it goes up to 1.1x, and then I have to multiply that by 1.05. And now I'm like doing a bunch of ugly math on a decimal. Or I could just plug a number in and say, you know what? These are all percents. Let's just make the computer start at $100. It goes up by 10%. That takes it up to $110. It's then going to go up by 5%, which is half of 10%. So if I want to go up by 10%, so another 10% of this would be, move the decimal place one, it'd be $11. So 5% would be half of that, which would be $5.50. And so I'm going to go from 110 up to 115.50. And there we go. There's my answer, D. Right? So I can plug in my own numbers. So this is our third way that we can recognize when we can plug in numbers. And it's the universe where no real values are given. This is one of my favorites. So a couple things about when we pick numbers. When we're in this must be true theory, we have to be ready to choose a few different cases. When it comes to our variables in our choices, we want to choose simple values, but we do have a cautionary tale here, right? I want to be very careful choosing anything that's like 0, 1, or repeats from the problem. And the reason is that the Gmat knows that this is a technique that we can use. And so not all the time, but sometimes we'll build answer choices that will give us the same answer as our correct answer if we happen to choose one of these like overly obvious or simple answers or simple values. So when we're plugging variables into the choices, we do want to be very careful of plugging in things like 0 or 1, or just repeating a number from the problem. When no real values are given, it's wild, wild west. You can do whatever you want, right? For the next two, so we've got this one and one more. For the next two, you can plug in literally whatever you want, as long as it's easy. Right? So when you've got things like percent problems, 100 is great. When you've got fractions, common denominators are great. Small, easy integers, right? Any of those things are awesome, as long as it fits the constraints of the problem. Okay, so they're not all going to be as easy, right, as that last one we just did. So let's try one that's, a little bit more difficult. Let's try this guy. I'll actually give you the full 2 plus a little bit for this. I'll give you 2.5 minutes to try this one out. And by all means, and no calculators. Yeah, you don't get calculators for this part of the test. So you have to be able to estimate your math or benchmark. If you are a person who is obsessed with the algebra, feel free to try the algebra first. I want you to see where it starts to, maybe get more difficult. Okay, so we've started to step up the difficulty a little bit with this one. Step up the difficulty. So we want to think through the problem, right? So step one for most word problems in general, I'll just like side tip. I read them a couple times. The first time I just read it to figure out what the heck's going on with the story. But then I start to notice like, hey, wait a minute. As I read this, I noticed there were no real values given. Everything was relative, right? They sold 3 times as many jeans as chinos. So there's like a ratio relationship. They made twice as much profit on one as the other, right? And so I want to look at plugging in my own values. So let's get some organization. I've got jeans and I've got chinos, right? And so for number of them sold, and let's look at the number of sold, they sold 3 times as many pairs of jeans. I'm just going to do 3 and 1 because I can pick whatever the heck I want when there are not variables in my answer choices. So I'm going to pick something very, very simple. So we sold 3 pairs of jeans and 1 pair of chinos. And we end up making twice as much profit for a pair of chinos as for a pair of jeans. So let's say we make $2 in profit on a pair of chinos, but only $1 in profit per pair. This is my profit in monies per pair. And so what percent of their profits? Ooh, okay, so what are their total profits? Let's go with that. Total profit. Well, I sold 3 pairs of jeans and I made $1 on each pair. I sold 1 pair of chinos and made $2. And so I, in total, made $5 in profit. What percent came from the chinos? 2 out of the $5 came from chinos, which you can memorize your equivalents. Or if I were to double this, it becomes 4 over 10, which is 40 over 100 or 40%. So 40% of my profit came from chinos. Be careful. A lot of people said D, 60, right? That's the profit from jeans. Yep, exactly. So we just got to slow down and read very carefully. But notice this isn't a lot of math. Once you give me real numbers to work with, right, it gets a lot easier, a whole lot easier, actually. So let's try one more. One more. Yeah, let's try this one. Figured you guys are ready for a challenge. I sort of snuck this one in there. I'll give you your 2-ish minutes again. Oh, no. Yeah, it's all there. The second sentence isn't irrelevant. They're not really ever going to be irrelevant. Not normally. We're almost always going to need all the information that we've been given. I'm getting like, oh my gosh, is it B? Is it A? Is it B? Notice that B is what happens if I literally just take 2/3 and multiply it by 3/5. I'd be a little nervous about B. Just saying. A little bit nervous. But that said, sounds like another kind of problem where we've got a couple different clubs. We've got them selling different numbers of raffle tickets and having different numbers of people. So organization is going to be really crucial. I don't have to spend as much time writing a million equations because I'm going to be plugging in, no real values given. And so I can put more effort behind how I want to arrange things. And often I think about Excel, right? How would I put this into an Excel spreadsheet? Well, I would have a row for the AV club and a row for the chess club. And each person in AV sells some number as many as each person. So I want to see like how many tickets per person. So every person in the AV sells 2/3 as many. So let's say the chess club sold 3. I'm going to be really simple again. That would mean that the AV sold 2. So each person in the AV club sells 2 tickets. Each person in the chess club. The next thing is about how many members there are. So this is my number of persons. Right? So if the AV has 3/5 as many members as the chess club. So not only does the AV club sell fewer tickets per person, there's just fewer people. Right? So the AV club's not doing as much work here. Just that's one thing to notice is the AV club's not doing as much work. And if I'm looking at fraction of all the tickets, that means AV club's going to be under half. So I better not pick anything C, D, or E. But now I'm between A and B. Number of people, let's say there are 5 people in the chess club, 3 people therefore in the AV club. If there are 3 people in AV, each selling 2 tickets, then my total number of tickets will be 6 and 15 respectively. Now it says what fraction of all the tickets sold by the 2 clubs. So I need the total number of tickets, which in this case is going to be 21. What fraction of them were sold by the AV club? It's 6 out of 21 tickets. I have to reduce it. They're both divisible by 3. And so this results in 2/7. And the answer choice A. Okay, so we're plugging in. Just because plugging in numbers moves us from algebra to arithmetic does not make plugging in numbers just easy right off the bat. You have to practice. If you want to be able to turn this ugly problem into this simple table, you have to practice, meaning that you have to try anytime something looks like you might be able to plug in smart numbers, you want to try to. It might not go very well. It might be very clunky at first. Totally fine. Maybe you don't time yourself when you're trying to do them, right? Yeah, so for the first column, we want to look at maybe a common denominator, right? Like this was just members of the AV club, how many tickets they were each selling. If AV sold 2/3 as many as the chess club, then if I pretend that the chess club sold 3, then the AV club sold 2, which is 2/3 of 3, and ditto for this one. Yeah, this is basically setting up ratios right now. Notice I set up the ratio 2 to 3, 3 to 5. Often the ratio is really the smart number because the ratios are you kind of picking values. So yeah, they're very much in the same vein. Smart numbers can extend this, like picking like numbers for yourself can extend beyond problems that are just ratios though. This will also work for problems where, it may feel more algebraic. All right, one final type. And these guys are my favorite. These are my favorite. So just to kind of recap where we are, we can pick numbers if they say things like must be true, must be even, must be positive, must be divisible by 3, blah, blah, blah. We can often pick numbers when there are variables and answer choices. And again, we want to be very careful of like 0 and 1. So this is the one kind of risky place. We just have to be careful. If no real values number are given, we just pick whatever the heck we want. right? Like 100, common denominator, off I go. Anything I want. All right, one final type of problem. We'll give this one a try. I'll give you a minute 45. All right, so this is my favorite type of pick your own number problem. And so you have to start to kind of cultivate your ability to see these. But once you see them, they're heaven. So far, we've seen problems where there are variables in the answer choices, right? We've seen that, where the variables are hanging out in the answer choices. And the reason why they're in the answer choices is because the question gives you a variable, but isn't asking you to solve for it. They're asking you to solve, like, in terms of that variable. Sometimes a problem will give you variables and then ask you to solve for it. So an example in this case would be like, if P is a prime number greater than 5, then, blah, 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 what is P? Question mark. So far we've got two options. I can give you a variable and make you solve for it, kind of standard algebra. I can give you a variable and make you solve around it, and that's how you end up with a variable in the answer choice. Or my favorite, I can give you a variable and it just disappears. You didn't have to solve for it. You don't have to see it in the answer choices. It just goes away, right? So notice we've got P. We're talking about a remainder when P squared is divided by 8, but I don't ever want to know what P is. I don't care what P is. I want to know the remainder. What I'm solving for is remainder. And so when I have a variable, right, they give me a variable and then it just magically goes away. I can pick any value I want for that variable. I don't have to be worried about it at all. And I only have to ever pick one value. So I don't have to test out a bunch. I pick the one value and I see what happens. So, which is great in this case because prime number is greater than 5. The next one is 7. And the next one after that is 11 and then 13, and they get a little bit bigger. So if I want to test this one out, right, I would say P is, let's call it 7. If I square 7, so P squared, that's 49. If I were to divide 49 by 8, right, 49 is the same as 48 plus 1. So as long as I break a number up into addition, this would be, the 48 would be divisible by 8, but then there'd be this 1 left over. So it's a remainder of 1. You could do the exact same thing with 11, right? So just to prove it to you, 121. And then I'm going to look for a number near 121 that's divisible by 8. And we'll kind of start to break this up. So let's call this like 80 plus 41, which I would write instead as 80 plus 40 plus 1. Now, if I wanted to take this number and divide it by 8, 8 goes into 80, so that would divide. 8 goes into 40, so that would divide. And there's my leftover 1. And again, I'm writing this out because we don't have a calculator. And I don't like to do longhand division. So no matter what P is, I keep getting the same result. And that's always going to happen if they gave me a variable that goes away. Because it can't be different for different variables because that variable just straight up disappears. So our fourth, and honestly, one of my favorite, is I can use them for problems where a variable disappears, right? Like from the beginning of the word problem to the end, or the beginning of whatever the problem is, we were introduced to a variable that then just magically goes away. I don't solve for it, and it's not in my answer choices. This one takes some practice, some learning to notice it. So we're going to try one more. Kind of in the similar vein, but just so you can practice. Okay, and I got a question in the background about like, okay, I'm not quite sure what you mean by the variable disappears. So you could imagine a problem that's like, if x plus y equals blah, 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 and the problem keeps going. And eventually at the end it goes, what is the value of x, question mark, and then you got your answer choices. 1, 2, 3, 15, 72, whatever, right? This is a problem where they have introduced, right? Maybe I want like, what's the value of x divided by y or something like that. This is where they've introduced variables and they've asked me to solve for them or solve for some aspect about them. Like what is it when I divide one of them by the other, whatever. But I'm being asked some specific value of the variable itself. So that's one option. The other one is, we've seen this with variables and answer choices, if x plus y equals blah, 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 you know, something. And then the question goes, what is the value of x in terms of y, question mark. In this case, the answer choices would have y in them. It would be like 2y, y minus 6, y divided by 3, never got a C, but you guys are getting the picture, right? Blah, 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 blah. So one option, the test gives you variables and then asks you to solve for them. Another option is the test gives you variables and then makes you carry them around, right? Like, what is the value of X, but in terms of this other variable? Right? So they now make you keep the variable. You never solve for it because it's in your answer choices. So the third scenario, when the test gives you a variable. So they give you a variable, you have to solve for it. They give you a variable, you end up like keeping it because it's still in the answer choices. They give you a variable, it just goes away on its own. Notice that when X is divided by 10, the quotient is Y with a remainder of 4. Okay, and if X and Y are both positive numbers, guess what? I'm not solving for X or Y here. I'm solving for what's the remainder. So like the identity of X and Y just sort of go away. And the reason why is that in problems like this, the X and the Y are just placeholders. Like in the last one, P, a prime number greater than 5, was just a placeholder. It didn't matter which prime number greater than 5 you used. It was going to work for all of them because the question wasn't asking you for P. In this case, the question isn't asking you for X. You're not going to solve for X or solve for Y. You're going to have to sort of work around it, but it's not something you're going to have to plug into answer choices. So here's what I know. Yeah, cool. So when I divide X by 10, when they say the quotient, they mean like the whole number part. So if I were to say 6 divided by 2, let's pick a number, it's not 6 divided by 5. The quotient part of this, like you can also think about this as a mixed number. This is the same as saying 1 and 1/5, right? The quotient is the whole number part. So basically what they're saying is that the quotient has to be a positive number. The way that that would not happen would be if, like, let's say I took 2 and divided by 3. This would have a quotient of 0 plus the remainder of 2. So this still does have a remainder. When 2 is divided by 3, there's a remainder of 2. It just doesn't have like a whole number part. So really what they're saying when they say the quotient is Y and Y is a positive number, they're just telling you that the number up top is bigger than the bottom. So they're telling you that X has to be bigger than 10. It's a really obnoxious way of saying it. Okay, so they've said in a really fancy, obnoxious way that X is a number bigger than 10, and that when I divide X by 10, it gives me a remainder of 4. So now I need to think about numbers that when I divide them by 10, give me a remainder of 4. And I can pick any ones I want. So I can pick 14. I can pick 24, 34, 44, right? Whatever, right? Because all of these divided by 10 would give me a remainder of 4. Rather than doing it with a bunch of, like logic behind it, let's just pretend. Okay, cool. Let's say that X is equal to 14. What's the remainder when I divide 14 by 5? Well, it goes into the 10 part of it, right? The 5 will go into the 10 part, but it won't go into this 4 part. So it means that the remainder is still 4. So the correct answer is E. This is a much harder one, right? A much harder one. But if I weren't going to think through it with a number, I would have to think through it theoretically, and holy cow, that's a giant mess. Or at least a lot more complicated to try and do in a time scenario. So here we have it, right? Can we pick numbers, and when, right? There's lots of times where we can pick numbers, lots and lots, right? And so some of those ones are things like must be true theory questions. Where's my slide? Right. We want to be ready to try a few cases. We've also got when we've got variables and answer choices. In this case, we want to avoid 0, 1, and repeating numbers. With no real values, we pick what we want. These would be things like 100 or common denominators. In the variable disappears, again, just pick based on the rules. And there you have it. The 4 scenarios on test day when you're dealing with problem-solving problems where you can plug your own numbers in so you don't have to do the stupid algebra that they want you to do. Practice these on problems that aren't crazy hard so that they work for you better when they get harder. Cool. You know, you can always come back and redo the lesson. You'll find it on our YouTube channel. Question in the back, and then I'll let you guys go. Back solving is when we plug the answer choices up into the problem. And so it is a version of picking numbers. It's just the version where the numbers you pick come from the answer choices. All right, guys. Thank you so much. Have a wonderful rest of your evening. It was a pleasure, or morning, evening, wherever you are. It was a pleasure getting to work with you guys. Once again, if there is anything you need from us, we have all sorts of free options. You can find out about our upcoming courses at Gmat at manhattanprep.com/Gmat/classes. Come check us out on our website for all sorts of other free stuff that we've got that you're welcome to use. And otherwise, good luck with your studies. You're going to be amazing. We're here to help if you need us.